the knee as our example of a synovial joint that we have to know a lot of detail about. But we'll look at some general characteristics and things like that all of our synovial joints share. So, synovial joints. In our synovial joints, our bones are separated by a fluid-filled cavity, a synovial cavity. And that cavity is full of synovial fluid. And that's what's going to allow the bones to slide past each other so that they can freely move. So again, all are considered diarthroses, which means they're freely movable, even though they allow varying ranges of motion. Almost all of our limb joints are synovial joints. We are going to look at the different characteristics of synovial joints. They have 6 general features. They all contain stuff called these little fluid-filled sacs called bursa or tendon sheaths. Stability is influenced by 3 factors we'll look at. They're going to allow several types of movements, and then we can classify all of them into 6 different types. So we're going to go through all of this pretty quickly. So as far as the general structure of a synovial joint goes, they all have articular cartilage. What kind of cartilage is articular cartilage? Hyaline cartilage that covers the ends of the bones. So hyaline cartilage that covers the bones in the joint. Then they all have a joint cavity or a synovial cavity, and this is a space that's full of synovial fluid, which is number 4. So our joint cavity, we'll just say this is a fluid-filled space. The third general feature of synovial joints is that they all have a joint capsule, an external fibrous layer, and an inner synovial membrane layer. This is a cellular layer. So external fibrous layer, what do you think of when you see fibrous by now? Some kind of collagen fibers, right? So dense, irregular, dense, regular. This is dense, irregular connective tissue. So for 3, we could say for our articular capsule or for our joint capsule, we've got 2 layers. The external fibrous layer has dense, irregular connective tissue. And then our inner synovial membrane. The inner membrane is going to be producing the fluid that fills the cavity. So we've got to have blood supply coming to it. So this is loose connective tissue, primarily areolar connective tissue. So our inner synovial membrane, we could say, is areolar. Your book just says loose, I think, but it's, areolar connective tissue. And then that inner layer then is secreting synovial fluid. It produces and creates synovial fluid that fills the cavity. So synovial fluid is thicker than water, and we find it in different types of filling the joint cavity, and then in different types of membranes surrounding and supporting the joint. So we'll just say this is a thick fluid that lubricates the joint. All of our synovial joints are going to have different kinds of reinforcing ligaments. And so ligaments attach bones to bones. So if I'm attaching a bone to a bone and I've got a fluid capsule in there and all this stuff, I can put some ligaments around it and reinforce the joint. So we'll just say these increase stability. And then all of our synovial joints also have nerves and blood vessels. We have to be able to have blood supply in there to make the synovial fluid and to support the living tissues there. And we also have to be able to feel. So if you pop something out of a synovial joint, you should feel that, and it should hurt real bad, real fast, so that you do something to protect it and go to the doctor and get it popped back in or something. So they're all living kind of structures, so they've got nerves and blood vessels. So these are the 6 general features that all synovial joints will have. So we'll have, you can see we've got 2 bones here, covered in articular cartilage, which is hyaline cartilage by type. We've got a joint cavity here. Then we've got our articular capsule with our inner synovial layer and our outer fibrous layer. Then we've got our synovial fluid filling the space, reinforcing ligaments on the outside, and this isn't showing our nerves and blood vessels, but they're there. Okay, questions on that? So then around joints we can find these things called bursa and tendon sheaths. And you've probably heard, like when you pop your knuckles, that sound is moving a bursa. It's like snapping it out of place for a minute. And what they are these bags of synovial fluid that act as like lubricating ball bearings in the joint. They're not necessarily strictly part of the synovial joint, but they're closely associated with it. And bursa are these little like membrane-bound sacs of synovial fluid. So that's what we'll use as our definition of a bursa. So they are membrane-bound sacs of synovial fluid. And then we have these other things that they're like bursa, but they're longer, called tendon sheaths. And they wrap around long tendons and ensheath them so that the tendons can pass over bones and things without rubbing. And so I wish, like, after you guys all left, she brought out the PA's cadavers, and they get to see their faces, they get to see their hands, and she was dissecting their foot. And so you could see all of the tendons and the tendon sheaths on the foot. And I was just like begging her, like, please, can we have the back of a hand, just the back? She was like, no, because of the workshops. So you get a bunch of high schoolers in there, and who knows what they're gonna do, I guess. But that's if you think about it, the muscles that control the movement of your hand and your fingers, most of them are in your arm. So to get from muscle to that bone, I've got to go across a lot of bones here. I have to go across all my metacarpals. And so there are nice big long tendon sheaths around all of those tendons that protect it from, that protect the tendons and the bones from rubbing against each other. So that's what a tendon sheath is. So a tendon sheath is just like a long bursa. We could just say it's an elongated bursa that surrounds, we'll say surrounding tendons, or surrounding long tendons.
So the face is only wrapped for the students? Or
For all undergraduates. The PA students, they're different, and so they're actually looking at all of the structures in it. I think that they're digging all the way down, it looks like. It's pretty awesome. Okay, any questions on anything so far? So, okay, then just something to be aware of. We have different factors that influence the stability of synovial joints. I'm not going to ask you to list the factors or anything like that. I just want to address them so that you're aware of it, so that we can like say, oh, I can see why the hip is so much stronger than the shoulder. So 3 factors determine it. The shape of the articular surface has a minor role. So shallower surfaces are less stable. So that glenohumeral joint is a really shallow surface compared to the acetabulum. That's a huge socket. So then ligament number and location. This also has a limited role, but the more ligaments you have, the stronger the joint. So we'll see the knee has a lot of reinforcing ligaments. It's a very strong joint. Really in the arm, sure, I've got ligaments, but mostly I have tendons because I got a lot of muscles in my arm, and that's attaching my muscles to my bones, so it's not quite as good. But another thing that helps with the stability of your joints is muscle tone. And so this is what will help to keep our tendons taut as they cross our joints. This is the most important thing for the stability of a joint. And this is really important in reinforcing your shoulder and knees, as well as the arches of your foot. We'll talk more about muscle tone soon in muscle chapter. But muscle tone is basically the slight state of muscle contraction that allows you to maintain posture and stuff. So that's also going to help support your synovial joints. So this next chart in your book goes through all of the synovial joints that we have in your body. You're gonna need to memorize every one and know the names of every bone and every articulating surface. That was just a joke. Take a breath. You